Assalamualaikum and hi everyone. My name is ADLINA binti ANWAR and my student ID is 2023866294.
And my name is ALYAA BALQIS binti Muhammad HALIMI 2023866932.
Hi and Assalamualaikum. My name is NAZURAH binti SHAHRIL. My student ID is 20238688. The objective of this experiment is to determine the volume and density of ball bearing, and secondly is to determine the volume and density of glass block. Introduction for this experiment. This experiment aims to dive into the principle of basic measurement. Experimenting with basic measurement of length, volume, and density provides a foundation understanding of these fundamental concepts. Also, we dive into the precision of length measurement, the intricacies of volume calculations, and the relationship between mass and volume to uncover the concept of density. Through hands-on activities and meticulous observation, this experiment aims to unveil the principles governing these crucial aspects of physical quantities, setting the stage for a deeper comprehension of scientific measurement techniques. Length, the extent of an object from one point to another, utilizing precision instruments such as micrometer, screw, gauge, and vernier calipers. Moreover, from this experiment, students gain knowledge through the intricacies of length measurement, emphasizing the importance of correct techniques and the significance of minimizing uncertainties. Next, we have density. Density is the mass per unit volume, is a fundamental property of matter. Furthermore, this experiment will guide students in the determination of density by measuring both mass and volume. Apparatus that we use in this experiment is vernier caliper, micrometer, screw gauge, weighting scale, ball bearing, and glass block. Next is procedure for micrometer screw gauge. First, determine the zero error. Measure the diameter of the ball bearing and repeat step 2 at least 3 times at different positions of the ball bearing. Record all the data in the table. Calculate the actual diameter reading, taking into consideration the zero error obtained earlier. Determine the weight of the ball bearing and calculate the density of the ball bearing. Procedure for vernier caliper. First, count the whole number of small deviations on the fixed part of the caliper that are to the left of the zero mark on the vernier. Find the first mark on the vernier that line up with one of the marks on the fixed part of the caliper. Determine the zero error of the vernier caliper. Measure the length, width, and the thickness of the glass block by using the vernier caliper. Repeat step 4 at least 3 times at different positions of the glass block. Record all the data in the table. Calculate the actual measurement by taking into consideration the zero error obtained earlier. Determine the weight of the glass block and calculate the density of the glass block.
So this is the result of the ball bearing measurement. For the average observed reading diameter of ball bearing, we got 20.27 millimeters, and for the average radius of the ball bearing, we got 10.133 millimeters. And the average true reading of diameter of ball bearing is 20.257 millimeters and 10.123 for the radius. And this is the result for glass block measurement.
Analysis of ball bearing. Firstly, to calculate the volume of ball bearing, we use the formula that has been given on datasheet. The formula is volume equal to 4 divided by 3 pi radius power of 3. Before that, we need to find radius. To find radius, we can get from the data which is 10.12 mm, and we need to change the SI unit from millimeter to meter. The result shown, radius is 0.010 meter. And then, calculate the volume uncertainties, which is the delta V. To calculate it, we can get from datasheet the zero error ball bearing. 0.01 millimeter change to millimeter, and we got 1 times 10 power of negative 5. After we got the radius and the answer to this, we put into the formula as 4 divided by 3 times pi times 0.010 power of 3. Pi number is 22 divided by 7, or we can put it as 3.14. And finally, we have got the radius equal to 4.190 times 10 power of negative 6 plus minus 1 times 10 power of negative 5 meter cube. Secondly, we calculate the density of the ball bearing using the formula given. The formula is density equal to mass divided by volume. Before we calculate the density, we need to change mass from gram to kilogram as SI unit. The mass of ball bearing is 27.74 gram divided by 1000 equal to 0.028 kilogram. And then we can put mass and volume into the formula, which is 0.028 kilogram divided by 4.190 times 10 power of negative 6 meter cube. The density is 6.682 times 10 power of 3 kilogram meter cube. Analysis glass block. First of all, list the data to make it easier to put on the formula that has been given. Liter equal to 10.65 cm. But we need to change to meter by divided 10.65 with 1000. So, we got liter equal to 0.107 meter. And then, both width and height divided by 100 to make it meter SI unit. Width equal to 1.94 times 10 power of negative 3 meter after we divided. Height equal to 6.45 times 10 power of negative 3 meter after we divided by 100. Next, to calculate glass block volume is liter times width times height. So, the volume equal to 0.107 times bracket 1.94 times 10 power of negative 3 bracket times 6.45 times 10 power of negative 3 bracket. After calculate it, we got 1.339 times 10 power of negative 3 meter cube. And then, we must find volume the uncertainties. To find it, 1.339 times width bracket 1 times 10 power of 5 divided by 0.107. And then, we plus with 1 times 10 power of negative 5 divided by 1.94 times 10 power of negative 3. And then, we plus again with 1 times 10 power of negative 5 divided by 6.45 times 10 power of negative 3. And lastly, put bracket. So, the answer to this equal to 9.10 times 10 power of negative 9. Volume equal to 1.339 times 10 power of negative 6 plus minus 9, 10 times 10 power of negative 9 meter cube. And then, to calculate the density, we use the same formula that we used to find density for ball bearing, which is density equal to mass divided by volume. And again, same with ball bearing, we need to change glass block mass from 289.69 gram to kilogram. To change it, we need to divide it by 1000. And after calculate it, we got equal to 0.2897 kilogram. After that, 0.2897 kilogram divided by 1.339 times 10 power of negative 6 meter cube. So, we got the density of glass block is 2.16 times 10 power of 5 kilogram meter cube.
This laboratory report discusses the methods and techniques employed in measuring the characteristic of ball bearing and glass block. Accurate measurement of their dimensions, tolerances and performance parameter is essential for ensuring optimal functionality. In this report, we outline the experimental setup, measurement procedures and data analysis involved in assessing key aspects of ball bearings and glass block. The vernier caliper allows you to measure external thickness, internal diameters and depth of holes. To measure an object's outer dimension, it is placed between the jaws, and the jaws are then moved together until they are secured. The screw clamp can be tightened to keep the reading unchanged while reading the scale. It is recommended to take many readings of each measurement and then calculate the arithmetic mean of the result. Comparing the minimum and the highest measured value give a more accurate estimation of the measurement error. Even smaller measurements may be taken with the micrometer screw gauge than with the vernier calipers. Additionally, a rotating thimble with an auxiliary scale mark on it is used by the micrometer screw gauge. The little ratchet knob may be used to rotate the thimble, which adjusts the jaws. The device also has a friction clutch to keep the tension from being applied excessively. To expand the jaws by 1 mm, the thimble needs to be turned twice. An object is measured by placing it between the jaws and rotating the thimble with the ratchet until the object is fit.
From this experiment, we were able to learn how to get accurate measurements and use the micrometer screw gauge and vernier caliper. This experiment allowed us to get a better understanding to practice using the different measuring instruments for the variety of objects. One of the main concepts we gained from this experiment was we learned how to determine the volume and density of ball bearing and glass block.